Hey guys, so in one of my recent videos, I got a question about SAT math. And so Sarah B, 1852 comments, can you teach me about geometry problems like when you find the length of one side of a figure? And she just goes on to say that she feels like she's really only stuck in those problems. There's going to be a really great formula to help solve this. I'm going to get into that in a minute, but real quick, just before I do that, I'm Percy, and I've been tutoring SAT math stuff for the past 8 years. I'm definitely an expert on the SAT and would love to answer any questions that you guys have. So if you do have any questions, please leave those in the comments of this video, of future videos, and I'll be happy to answer those questions. Okay, now let's dive into the example here. So what we're looking at is she's asking about like finding the distance between 2 points essentially. And so if you look at this in the algebraic context, you're going to use the distance formula specifically. And so the distance formula, I'm going to do a little screen recording here in a bit, and I'll show how to solve an example problem. But just as a little preamble to this, the distance formula uses, you have to have 1 point over here, 1 point over here, right? And to find the distance between the two things, use the following formula. It's going to be the square root of the following. It's going to be the parenthesis group with x2 minus x1 in it, quantity squared, plus parenthesis group y2 minus y1, quantity squared. And so essentially what you're doing is you're finding, so you have 2 coordinate points, right? You're finding the difference between the x coordinates of those points, squaring that. You're also finding the distance between the y coordinates of those 2 points, squaring that, adding those squared amounts up, and then taking the square root. Okay, let's dive into the screen recording. Okay, so here's a demo of how to find the distance of a side length of a shape. So as you can see, I've made a triangle in Desmos, and let's go between the 2 points of 3, 2, which is in the blue on the bottom, and then 5, 9, which is the upper right, labeled in green there. Okay, so 3, 2, and 5, 9. I'm going to call 3, 2 my first point, and so that'll be labeled as the x1 coordinate and the y1 coordinate. So x1 is 3, and then y1 is equal to 2. And then I'm going to do the same thing with 5, 9, but it's going to be x2 is going to be 5, and then y2 is going to be 9. Okay, so those labels are going to come in important here because basically we have our distance formula, and the distance formula is using x2, x1, y2, y1, which we have already labeled with the points that we are finding the distance between. Okay, so next thing to do is plug everything in where it belongs, right? So x2 is 5, and then x1 is 3, so we plug those in, and then y2 is 9, and y1 is 2. And so at this point, we're just kind of calculating inside this distance formula. Okay, so next thing we do is 5 minus 3, and then 9 minus 2 each. And so 5 minus 3 gives us 2, and 9 minus 2 gives us 7. And so we just square those results. We get 4 plus 49, and then we get a final answer of 53 inside the square root. And so what that means is that the distance between points 3, 2, and 5, 9 on our triangle shape is the square root of 53, and that would be put in whatever units the problem gives you. So if those were in terms of inches, you would say, okay, the distance between those 2 points on that side length is square root of 53 inches.